I'm going to show you a set of pictures and explain you the way that carbon gets stored in the soil, and in fact more, why is the soil a factor for our battle actually to sequester carbon from the atmosphere. Sven said briefly that it's a forgotten resource, in fact, but I think it's so far largely neglected. We didn't realize that we can use the soil for this purpose. And so in Dutch, obviously, this is what we call earth, aarde. And this is also what we call aarde, earth. And the previous one has a diameter of about 12,000 kilometers. That's our planet. And the measure that comes with this amount of Earth is far more in the range, in the magnitude order of 1 meter. And in many, many places on the planet now, it's far less than 1 meter. And that's the problem. How did this earth, so the fertile earth, the earth that we use as our topsoil, where we actually directly or indirectly get all our food from, how did it come about? Well, those are great forces. There is heat, there is cold and weight of the glaciers. There is the power of water and the power of wind that shape what we now walk on every day without realizing much about it. And these huge forces have molded the rock material, the mother material, into various classes of size. And so these are the English terms that we use. And the 3 categories of size that we find most interesting are shown here. Sand is the largest one. Then we have silt, which is a general term for a large group. And then we have clay. So this is all very briefly the physical matter that is part of what we call soil. And so every amount of soil, wherever we are, is a mixture of certain amounts of these categories, these 3 sizes. We find mixed in many different ways. And if we only talk about that physical material, which is also, when we generally talk about nutrients, we refer to the mineral fraction of soil. And we look at the left picture, this is what we find. It's just rock in some sort of exposure, whether it's in flatlands or whether it's in mountains. But it's just physical matter exposed to sun, to weather, to rain, and to temperature differences. And just because on our very planet there is something that we call life, this at some point in time, this life infected maybe, became part of this matter and started modifying it. And this is, of course, a very simplified range of modifications where life becomes life, as we all know, of course. So life starts at the microscopic level. And of course, we have eons and eons of evolution, but then the life forms become more complex, and they also create the circumstances for more life to appear. And so all these very basic givens of physical matter and life lead to countless different types of soil on the planet. This is just one shelf in a whole museum of samples of soil. And all these very different samples of soil have, of course, been the mother material out of which, onto which all these ecosystems of also very, very many different kinds have grown, and that we know. So obviously soil was there before we started to mess with it, let's say. Now, in the Netherlands, we have not been very aware of soil, of what it needs, of what it can do for us also. And I tend to say we used to be 3 times lucky, because there's 3 big factors that make it very easy for us so far. As a delta, we get the sediment, which is the minerals from erosion from half of Europe, passes by. This is why we're so fertile, technically speaking. Then, of course, the soil is going nowhere, because just Netherlands and a few more places in the world, the surface isn't slanted, isn't at an angle, so soil is just going nowhere. And the third one was, particularly in the Netherlands, which is very rare even, is that we always have water at hand. Our problem was to get rid of it, because there used to be too much. And I say used to, because this is now changing. So that third one, for a larger and larger part of the country, that isn't true anymore. And where farmers all around the world were more aware that they needed to take care of their soil, because then also they wouldn't have water, this is what we're finding out. And I say, welcome to the world. So if we talk about agricultural soils, because that's obviously the soil that we use most intensively, we have a rough partition of what that should contain. So if we talk about soil and fertility, we usually refer to just the red part, the mineral particles. But in a functioning soil, healthy soil, we have roughly also a quarter of air, because the soil life needs to breathe. And we have, of course, moisture. And I say moisture, which is different maybe from water, but moisture is far more finely part of the soil. And then we have a smaller part that is organic matter, and that encompasses all the forms in which carbon, which is the stuff of life, has shaped itself and is to be found. So it says organisms, those would be live organisms. So that's the multitude of microscopic life. We talk about roots, which is also, of course, underground, still parts of plants or maybe died off, and humus. And so humus is easily said, but what is humus? This would be humus. That is to say, this is, how do you say, an approximation of a molecule that could be part of a humic set, and it's also just in 2 dimensions, of course. And if you realize that on every single corner in this structure, there is a carbon atom, but we don't write them because then we couldn't actually see the picture anymore. You can see that this is really the skeleton of life, and that is mostly carbon. And there are some other uh, molecules like the oxygen and the hydrogen that we see, and a few more, but most of it is carbon. And so this is the carbon that is part of the living soil, and that actually is the best way to express the life of the soil. How does the carbon get into the soil? Well, this is, of course, through the process, which is itself, we take it for granted also, but it's a true miracle. The process by which, of photosynthesis, by which carbon in the form of carbon dioxide that lives in the atmosphere is taken up by plants. And if we think that we want to raise the organic matter in the soil, which is a way, which would be part of sequestering it, most people would think, okay, then this is about composting. It's about taking care that the manure goes back to the land. This is all true, but a new insight in science, which really hasn't come out to, this is what we call like a new frontier actually, is that growing plants themselves transport the products of the photosynthesis, so the sugars, they transport them down to their roots into the soil, far more than we know. And this is where they feed soil organisms, soil life. So if you don't have growing plants, you don't actually feed soil life. So you stop having soil life at some point. And so yeah, an expensive word is that it says in the right corner, carbohydrates are exuded. So this is a major way by which carbon gets into the soil. Then the thing becomes more, how can we keep it there? So soil life is actually I find the key to this whole process. Soil life is also, in that sense, the key to fertility as such, because you may have minerals in your soil, but if you don't have the soil life, they will not get to your plant, and they will not exchange as much. So this is really where it happens, in the interaction between roots and soil particles and the soil life that you cannot individually see on a picture like this. And by now, let me see what's the next picture. Right. These are 5 Dutch farmers that feature in my film, Soil Farmers. And they are people, they're all organic farmers. They have found out how soil life works for them. Because I think we can say conventional farming, we do a lot of things that cost fossil fuels and that cost us our backs maybe, that we can invite and allow and tease maybe nature to do. And it starts with soil life. If you understand, if you're interested, and then you will learn about soil life and what it can do for farming and for the quality of our farming products. So if we want to talk about sequestering carbon into the soil, people will probably more easily think of planting trees and seeing the biomass grow, maybe on top of soil and also as roots. But that is valid. Of course, planting trees on huge scale is going to help us there. But we can also do more in farming itself. And okay, let's look at this a bit for the proportion of, if we look in the right corner down, how do you say, soil organic matter, 45% of it all is where it can be stored. So that is roughly the same kind of amount as we store above ground. And here you can see that the carbon pool like really accumulated on all places, all corners of the world. If we look at soil, the amount of carbon that used to be stored in there and deeper than we actually touch is major. And so the fossil fuel that has been mined and burned and so allowed to poison actually the atmosphere and the climate is on the same level as the carbon that is there as a pool in the soil, also in the deeper soil, and we need to understand far more of that. And in terms of how can we make this work, the branch of farming that is developing fast, that shows us that this can work, is actually cattle grazing. So we have forestry, food forestry. This is what Hillebrand will talk about. I think there's a question mark about how we can transform our arable farming into something that is more regenerative and sustainable, but grazing, the new brand of grazing, holistic management, there's many types, there's many terms for that already. So that is proving to be a positive, where we do not just take from the land, but we actually build soil actively, net carbon, turn into the soil, also storing, increasing the capacity to store water, because that goes one-on-one together. And this is a very zoomed out picture that can show you a difference between what we do now, continuous grazing, and regenerative grazing, and the amount of brown is directly indicating the amount of humus on the right side. This is another dramatic, just example, sorry, from Australia, I guess, where on the left side of the fence, obviously something else has happened on the right side. Sorry. And I found this picture, which must be an image in an exhibition that has been set up only in the last few years or so, because this branch of farming, this regenerative farming using types of grasses that have roots that go down as deeply as you can see. This is really the new science coming together, and the new science also inspiring the practice. And I think it's a real powerful movement that we all should become more part of. And my last picture is just the link to the film that was actually made already 5 years ago for the UN Year of the Soil, even before this whole regenerative farming came to the fore. That's my story.
Are there any questions for clarification right now before we go to Hillebrand?
I think Boudewijn is asking a question. What do you think of biochar as a soil enhancer and as a CO2 sequestering vehicle? So biochar.
So biochar is actually charcoal, and to me, it wouldn't be a strategy to really explore or to really invest much in. It would really depend on where it would be applied and what alternatives are there, because charcoal is actually inert carbon. It doesn't chemically react with anything. And we need live carbon, far more, in the soil. What it can do, and that depends on where it's applied. If, like parts of Africa, for sure, there is nothing after the Green Revolution, so after we've mined the old soils in Africa using like the Green Revolution and stuff, if there's nothing left, then there's also no place left for microorganisms to live. And I've understood that that's a factor, that the miniature crevices that you add in the charcoal, if you put it, if you spread it on the soil, it would help. It would be like just, a cave for microorganism, bacteria and fungi possibly. And so that would help them to establish themselves. And then you would need to do other things to make sure that they can actually be effective in regenerating the soil. But in itself, I'm very skeptical also, because to make charcoal, we also need, again, lots of energy. It's a high-tech process that, and high-tech processes tend to be associated with particular types of investment, and they don't, empower, basically. So that's my response.
Hillebrand, thank you also for being with us. And I think it's wonderful to continue on the groundwork, literally, right now. Would you please take us on your journey into
Can you see my presentation now?
Forestry? Yeah, I can see your presentation. We can see it probably all. And you were always very vivid in telling guys, if we take this food forestry approach, then we combine all those things we need to survive as a species, and maybe even and carbon storage is maybe even an extra, but we also provide food and meaningful work, and we most of all we bring back life, which also was the main theme in Fransjan, your story. Like you spoke about the skeleton of life, literally. So, Hillebrand, please go ahead.
Yeah, you're right. I'm enthusiastic about food forestry because, I really think it's the rescue of mankind. Because as a policy maker at the province of North Holland, we are confronted with a lot of issues. And when I became aware of the existence of food forestry, I saw all those big issues come together. And maybe it's a bold statement, but I'm daring to make it. At first, it's a real honor to tell something about food forestry. After Fransjan, he is really the front runner of food forestry in the Netherlands. So I'm really glad and honored to do that at the front. To start, actually, what is food forestry? And as I learned it, food forestry is an agricultural system. And I had the education as I'm an agricultural engineer, and for me it's a quite new agricultural system, because on the agricultural school I learned cattle, dairy cattle, all monoculture, 17 different types of agriculture, and now there is one is combining a lot of that. But what is the definition of agricultural of this agricultural system, food forestry? In the beginning, it's man-made, and actually, man is trying to trying to copy a food forest of a forest about, and normally a forest about 500 years old, but we try to copy the principles of an old forest, and a food forest is quite a young forest, and it's man-made. You put all kinds of plants together, plants from the Netherlands and plants from abroad. And it is a big variety of mainly wood-based species. As I said, it's based on the principle of a natural forest. And it's self-sufficient, because in a food forest, you don't need all those labor you do when you have a normal agricultural farm. For example, you don't need manure, artificial fertilizer, crop chemicals, and also you do soil tillage. You don't do either. The forest is taking care of everything. And in food forestry, we use the principle of over-yielding capacity. That means that you produce in abundance, and there is enough left for people. That's actually, in a nutshell, the principle of food forest. Now you over here you see a great picture of how a food forest can be, and in food forest has, as I learned, 9 different layers. And in the picture you see the water. That is the first layer. In the water you have the water plants, and the second layer is actually your soil plants. Then your normal plants and the bushes, and your fruit trees, your big trees, your climbers, and also you can grow your mushrooms. So in a food forestry you have all kinds of layers, and that's also one of the things that make a food forest. And the bold statement about food forestry is the rescue of mankind, is because biodiversity is really bad, especially in the Netherlands. And with our nature policy, we can get back to the levels which we had around the Second World War. But food forestry can bring back for a big part the loss of biodiversity, and also can regenerate the soil, but what Fransjan was speaking about. The other big benefit of food forestry is this store CO2, and on a big scale, and for a human being it's more important because it brings healthy food, which is more suitable for the human genome. The food we get these days is not really healthy for us. The human genome is actually the same as about 10,000 years ago, when we were hunter-gatherers, and I think in food forest the food you can get there is more suitable for our body. So it will make us healthier. Another benefit is it can bring us the welfare we need, but maybe you have to redefine welfare, because what is welfare? To have a lot of money, a lot of things, or you can define the welfare of live in peace and in a great green environment, and in an environment that has everything you need, so like food, cosmetic, minerals, bioplastic, etc., etc., all the things you need every day. And another benefit is when you put food forestry in the cities, it can decrease heat stress, and also with a lot of rain and dry and food forestry is very climate adaptable. So here are a few benefits. For farmers, it is also a very social system. When a farmer has a food forest in his system, on his company, then more people are coming, so they have more connection with the neighborhood. Now a statement I want to discuss with you is human is the only species on earth who pays for his food, and that's actually quite strange. Why do we have to pay for our food? Why? Why isn't food like air for free? Why do we have to pay for this? And maybe you can say from what would a world be with a part of our food just be for free? Maybe not everything, but a big part for free. And I want to make a little future jump with you guys. And I thought about John Lennon, about Imagine, but another Imagine, like a world with food forests all around us. Can you imagine that 50% of public space, our industrial areas, our city, our buildings for vertical agricultural, if 50% of our public space is food forestry, and where is the food for free? So the public space is all food forestry, it's all for free. You can, and we all harvest and maintain it together. And we've seen those examples, and we make some such example on the Sluistein complex. And maybe imagine that 30% of our agricultural ground is also food forestry. That farmers combine food forestry with their dairy farm or with their crops, and make new systems. And my question to you is, what would that mean, and how do we get there?